Physics problem number 1. A basketball with a radius of 0.119 meters revolves on Robel's fingers 6 times per second. Calculate the tangential velocity of the edge of the ball. We know that the radius of the ball is 0.119 meters, and that the frequency of the ball is 6 revolutions per second. This implies that the period is 1/6 of a second. We can now substitute our known values into the tangential velocity equation. For our final answer, we get that the tangential velocity is 4.486 meters per second.
No buckets. Get out of here.
You're bad, Robel.
Alright, 2v2. Alright, it's good. It's good.
Alright, say less.
Physics problem number 2. Austin shoots a 0.62 kilogram basketball from half court at a launch speed of 11.79 meters per second and at a launch angle of 49 degrees. If Austin's launch time is 0.6 seconds, what is the force applied on the ball? So our known values are the mass of the ball, which is 0.62, the launch angle is 49 degrees, the launch time is 0.6 seconds, the V initial would be 0, and the V final in this case is 11.79. So we can solve this through the Newton's second law, and we first use the equation VF is equal to VI plus AT, and then we substitute our values, which would be 11.79 is equal to 0.6A, and acceleration would be equal to 19.65 meters per second squared once you divide 11.79 divided by 0.6. And then you use the Newton's second law equation and make ma equal to Fp, which is the force applied on the ball. And Fp would be equal to 0.62 the mass times acceleration, which is 19.65. And the force of the push would then amount to 12.18 newtons. And an alternative method to solve this is through the impulse equation. And it would be I impulse is equal to Ft is equal to mv minus mvi, or the change in p, and you would therefore get the same answer.
Physics problem number 3. As the shot clock ticks down, Austin shoots the basketball from half court at an angle of 49 degrees. If Austin is 1.75 meters tall and the basketball hoop stands 10 feet above the ground, at what initial speed did he have to shoot the ball in order to make the basket? Our known values is delta x, which is half court to the hoop, being 42 feet, which when converted is 12.8 meters. Delta y, which is the height of the hoop minus the height of Austin, being 10 feet minus 1.75 meters, which equals 1.3 meters. Acceleration y, which is the acceleration of gravity, being negative 9.8 meters per second squared. And then time, which we can calculate from the video, being roughly 1.65 seconds. In order to solve for initial speed, we use the kinematics equation. Delta x equals v initial x times time plus 1/2 times acceleration x times t squared. Once we plug in our known values, we get 12.8 meters equals v initial x times 1.65 seconds plus 1/2 times 0 times t squared. When we divide 1.65 seconds on each side, we got 7.758 meters per second is equal to v initial times cosine 49. When we divide 7.758 meters per second by cosine 49, we get v initial is roughly 11.8 meters per second.
Watch out.
physics problem number 4.
Austin punches Robel with a force of 800 newtons. Austin's fist, which weighs 1.9 kilograms, is in contact with Robel for 0.08 seconds. What is the velocity and acceleration of Austin's punch on Robel? What is the impulse of the punch? For the known values, we know the force of the punch is 800 newtons. T is equal to 0.08 seconds. The mass of Austin's fist is 1.9 kilograms. And V initial is 0 meters per second. To solve for V final, we use I is equal to Ft, which is equal to mv final minus mv initial. We plug in the known values and we get 800 times 0.08 is equal to 1.9 V final. When we solve for V final, we get V final is equal to 33.68 meters per second. To solve for acceleration, we use E of x is equal to ma, which is equal to f punch. When we plug in the known values, we get 1.9a is equal to 800. And when we solve for acceleration, we get 42 meters per second squared. To solve for impulse, we use I is equal to Ft, and when we plug in the known values, we get 800 times 0.08 is equal to I, and when we solve for impulse, we get impulse is equal to 64.
Physics problem number 5. Robel is punched by Austin, and Austin runs away with a speed of 5 meters per second. Austin has a mass of 60 kilograms and is chased by Robel with a mass of 70 kilograms. Right before impact, Robel is running at a speed of 7 meters per second and tackles Austin in a perfectly inelastic collision. What is the speed of Robel and Austin after the collision as they fall together? To solve this equation, we will use the conservation of momentum for perfect inelastic collisions. First, set the initial momentum equal to the final momentum. The initial momentum includes the initial momentum of Robel plus the initial momentum of Austin, which is set equal to the final momentum that includes the final momentum of both Robel and Austin. Then, we plug in the equation for momentum, which is mass times velocity, and plug in our known variables. By doing this, can we solve for the final velocity of both Robel and Austin, which, after solving the equation, is equivalent to 6.0769 meters per second.